This is the prep packet video for Unit 4, and this is part of the introduction series. In this video, we're talking about adding and subtracting with exponents. This is an important section, and a lot of people have trouble with it, but I don't think anyone will after they look at this video. What I want you to remember is that if you are working with variables or numbers with exponents, you have to be able to say that the base and the exponent is the same. So this is a base and this is the exponent. You can only combine this with another thing that is exactly like it. I cannot combine this and this. These are different units. These are almost like different variables. So here we go. If the bases and the exponents are the same, you can treat the exponential expression like a variable and just combine like terms. So just like x plus x equals 2x because you have two of them, or 3y plus 2y equals 5y because you have 5 y's, you can combine x squared plus x squared. You have two of these chunks, so there's 2x squared. Or if you have 6x squared, there's a chunk, plus 3x squared, you have 9x squared. Just remember, this is important, that's why it's in red. You can't combine unlike terms. X squared and x to the third stay the same because they are not like terms. X squared and x to the third are not the same because they're not the same number. And if you transfer that into just actual real numbers, you know instinctively that 2 squared is not the same as 2 cubed. 2 times 2 does not equal 2 times 2 times 2, because does 4 equal 8? No. Really, really important. A lot of people really try to do this. So this is a yes. This is a no. Okay? So really, stop and copy. Very important. And then we'll move on to a practice. So here we have the practice sheet. And the first thing I'm going to look is to make sure, are my bases the same and are my exponents the same? If they are, I can combine. So here's two chunks of a to the fourth. And that will end up, if I simplify it, just to 2a to the fourth, because that's the chunk I'm looking at. Here's a little something to think about. Here's some multiplication going on. But what would happen if I added it? 2b squared plus b squared. Can I do that? Let's see. My chunk is b squared and there's another b squared. So I can add them. It's a legal move. And I have 2 there and 1 there, so it's just 3b squared. Here's another one that's a subtraction problem. The first thing I'm going to check to make sure I have matching terms, and I do. So 6 of those minus 1 of those would be 5 of those. Next one, do I have a match? C to the 14th, C to the 14th, good. So 1 of those plus 14 of those would be 15 of those. Next one, do I have a match? R to the second, R to the second, good. And here I have negative 5 of those plus another negative, so I'll have negative 6r squared. Let's move on. These are pretty fast. Here I have a to the second, oh dear, and b to the second. Are they a match? No, they are not. So that's just going to stay the same, a squared plus b squared. How about this one? Do I have a match? M to the second and I have the same bases, but I don't have the same variables. So again, that is going to stay the same because m to the second is not the same value as m to the x. So I can't combine them. Let's look down here. Let's see. I have a to the 1/2 plus a to the 1/2. Oh, and this is really tempting, you guys. You would love to say, yes, that's a to the 1, but it's actually not because you're counting the chunks. I have a to the 1/2 plus a to the 1/2. That gives me, I got two of, come on, I have two of them. Okay. Yes, there are coincidences involved with that, but right now I want you to think of it as one chunk plus one chunk equals two chunks. So go ahead and stop and copy, catch up if you need to, and we'll see you in the next one.